Hey everyone, it's Mr. Glover here. Just about to do a couple problems. We'll do the warm-up together for our video today. So the topics on these videos are compound interest problems, just like we've been working on in our other videos. But we're going to be solving for some different variables today. So instead of solving just for the future value of an investment, we're going to start solving for some other things. So the first question we'll solve for the initial investment, and then the second question we'll solve for the interest rate. So Mrs. Hayes needs to save $10,000 in order to buy a ginkgo biloba tree for her house. She finds an investment that pays 9% annual interest compounded quarterly. How much will she need to invest today if she plans to buy her tree in 5 years? So we've got a bit of unpacking to do with this question. So let's list our variables. We've got $10,000 is our goal. So A is going to be $10,000 in order to buy a ginkgo biloba tree for her house. She finds an investment that pays 9% annual interest. So I equals 9%, which is 0.09. Compounded quarterly. So there's 4 compounding periods in a year. How much will she need to invest today if she plans to buy her tree in 5 years? Well, time T is 5 years, and A naught is our unknown in this case. So we can use the compound interest formula. A equals A naught times 1 plus I over N to the NT. And then we've got some choices to make. Do we want to plug our numbers in first, or do we want to move everything around first, then plug the numbers in? That's how I'm going to do it, because it'll be slightly less work that way. So I need to isolate A naught. That's my goal, is to solve for this. So I need to take everything else and I need to remove it and move it to the other side. Fortunately, since this is all being multiplied by A naught, I can just divide by this whole term all at once. So I can take A and simply divide it by 1 plus I over N to the NT equals A naught. And then I can just put my numbers in. Fortunately, this was all in one term. Otherwise, we might have had to do a little bit more work. But this is actually not that bad of a variable to find. So we put in our numbers. A is 10,000 divided by 1 plus I over N. 1 plus 0.09 over N, which is 4, to the power of NT, which is 4 times 5. So we've got a bit of simplifying to do. First of all, we should divide 0.9 by 4. This will simplify into 10,000 divided by 1.0225 to the power 20. At this point, you could probably plug it into your calculator. You could have done it in this first step or the third step, but this is much easier to put in a calculator. So let's do that. And we get $6,408.16 as our A naught. Which means that she would need this much money to invest initially in order to achieve $10,000 in 5 years. Now, there's a couple of things to think about here, and we'll talk a bit about more this context a little bit more tomorrow. But you got to remember, higher interest rates lead to higher risk, which means 9% interest is not the safest investment usually. So you want to go for higher interest rates, but they may not be that achievable without assuming some risk. All right, let's try one more of these questions for today. I guess we should write our answer in here. A naught equals $6,408.16. All right, if she invests $5,000 for 10 years, what interest rate will she need compounded quarterly in order to achieve a future value of $10,000? All right, this one's going to be a little bit trickier, a little bit more work for us. We're going to start by writing out our variables. So she invests $5,000. A naught is $5,000. Future value of 10,000, so A is 10,000. We've got a term of 10 years, T equals 10 years. And we know that it's compounded quarterly, so N equals 4 compounding periods per year. What we don't know is our interest rate, okay? So we start out with the equation, A equals A naught times 1 plus I over N to the NT. And then we have we've got a choice to make. Do we want to rearrange everything generally with variables, or do we want to plug in some numbers? And I usually solve for the variable I want first and then plug my numbers in because it's a little bit less work that way. But because we're actually going to have to take the nth root, it's going to be really weird if we leave it all in this form. I think putting some numbers in might make this a little bit less ugly to rearrange. So we're going to do it that way this time, but you can do it either way. A is 10,000, which equals A naught, which is 5,000, times 1 plus I over 4 to the power NT, which is 4 times 10. Okay, we'll do a bit of rearranging now. We've got to move this 5,000 over by dividing it. 10,000 over 5,000 is just 2. So 2 equals 1 plus I over 4 to the power 40. Now, we got to get rid of this exponent, and in order to do that, we have to take a root. Think about this as being similar to an equation like, I don't know, 5 equals x squared. We need to get access to the x, so we would take the square root of 5 to get there. It's the same thing. This is your x, but it's not a squared this time. It's to the power 40. So we have to take the 40th root of 2. 40th root of 2 equals 1 plus I over 4. And you might be asking yourself, well, how do I take the 40th root? There's actually some calculators do have this button, but most calculators, they've got a square root and that's it. So you need to remember that the 40th root can be written as an exponent. It can be written as 2 to the 1 over 40. This equals 1 plus I over 4. We've got to then subtract 1. 2 to the 1 over 40 minus 1 equals I over 4. And then the last thing we've got to do is we've got to take this 4 and multiply everything by 4. So 4 times 2 to the 1 over 40 minus 1 equals I. Now we can go ahead and start plugging things into our calculator. We can do it all at once, or we can do it separately. I'm going to do the brackets first. So I get 4 times 0.0175 equals I. Multiply by 4, and we have our interest rate. 0.0699 equals I. So in order to turn this into a percentage, like 5%, 7%, 10%, we have to actually multiply by 100. So that's what we're going to do. 0.0, I'm just going to call it 7 times 100% gets me 7%. And so our answer, what's the interest rate required? Well, the interest rate I must be 7% compounded quarterly in order to get $10,000 in 5 years. So there's a couple of different questions. I want to keep the video fairly short today because it is a weekend and some people will actually watch it today. So I want to make sure that you're not spending 40 minutes on your Sunday. There's 2 different questions. Both of them are solving for different variables. So now we've essentially solved for every variable. The only thing we haven't solved for yet is n. And n is going to be tricky to solve for because it's in our exponent. So in order to solve for it, we could use graphing technology, or we can use logarithms. But for now, we're not going to be solving for that. So that's where I'm going to end the notes today. It's a fairly short video. I don't have a new assignment for you, so you've got a bit of a break. Tomorrow we're going to go through a couple more problems, and I want to spend some time talking about compound interest and talking about investments. So that'll be the bulk of our notes tomorrow. So in the video, have yourselves a great rest of the day, and I'll see you all tomorrow.